So we're going to discuss Isaac Newton today, a little break from the usual perhaps. And let me start by helping you focus on what I want you to know from this lecture. It's a little unconventional to talk about history in a math class, but I hope it's a welcome break for you. So some of the things I want you to get out of this little bit about Isaac Newton are some of the three discoveries that he made during his miracle years. So talk about those. Why did he have a dispute with Leibniz, Gottfried Wilhelm Leibniz, another famous mathematician of that time? And pick up a few other things. Okay, I'm telling you most of what I want you to know, but you should pick up something else as well. So figure out something about Isaac Newton that surprised you, something that interests you, etc. So with that, let me commence here talking about Sir Isaac Newton. All right, so Isaac Newton was born in a small town called Woolsthorpe. It's a couple hours north of London. So this map was taken from Isaac Newton's diary. He relied on Google Maps, so pretty cool. He was ahead of his time. Ironically, this is Newton's house, and when I say ironically, the interesting thing about it is this symbol here. Now, I'll probably have the occasion to pull up a picture of this late in the semester when we finally get around to integration. But this symbol that we use for integration was not the symbol that Isaac Newton used. Newton had a different notation for that. So it's funny that this is somehow in his house. I can't help but look at that and say, oh, but that's an integral symbol. But that's not his notation. So a couple of remarks about his childhood. He was born on Christmas Day, but that was in a reform calendar. Calendar reform was instituted by Pope Gregory because before then, dates would kind of fluctuate. And they wanted to know when to celebrate Easter, when to plant their crops, etc. So Pope Gregory helped usher in calendar reform. His father died before he was born. So his mother remarried. She married a pastor by the name of Barnabas Smith. And Barnabas Smith apparently wasn't really concerned about raising his kids too much because he was like 70 years old and he fathered 3 kids with Newton's mother like right away. He sent off Newton to be raised by his maternal grandmother. And then when Barnabas Smith died, his mom moved back into the family home, which was a farm, and Newton was raised there until he went away to college. There's a couple neat stories about his early childhood. I'm not going to dwell on those. One regards a fight that he had with one of the local schoolboys, and he really beat the snot out of him. And according to some historians, particularly Richard Westphal, that kind of prompted Newton to try and show him up and try and not excel just physically, but also mentally. He became a real star in the classroom at that point. So, in any case, I do want to fast forward a little bit to his acceptance to Trinity College. And this is certainly a big, important, and transformative thing in his life. The interesting thing was, even though he was accepted at Trinity College and his mom could afford the tuition, mom didn't really chip in all that much. So in order to make ends meet, Newton was what they call a sizer. And basically that meant he was a servant. He would go clean up plates in the mess hall, even clean chamber pots. So not really all that fun for young little Isaac. But, he's made his way through Trinity College. But in the year 1665, the plague hit Cambridge, and they closed it down for a year and a half. So he retired to the family home, and he started thinking, just doing research and thoughts on his own. So at this point, he's like 22 years old or so, and this picture is just wonderful because it shows so much of what he did and thought of during this year. So what's this little object down here in Isaac's hand? A prism. He experimented with light and prisms, and he figured out he defined his theory of light being propagated as a bunch of particles. So that was different than the prevailing theory at the time. Also, you see these orbs going around the sun. He worked on gravity, and gravity's motion or gravity's effects determine the path of a planet as it orbits the sun. Of course, there's the famous story regarding this, right? The apple, where he was inspired to think about gravity because he saw an apple falling from a tree. Now, he told various stories about this during his life, and they always seem to change a little bit. So it's hard to know what really happened. It's kind of probably apocryphal that it may have not actually happened. There was also some stories about Einstein and his inspiration, because he came up with a theory of gravity that actually replaced Newton's. It was just a little bit more general, his general theory of relativity, and he was said to be inspired by seeing somebody fall off of a platform, a construction worker. But Einstein's like, and I don't think Einstein would look at that and go, gee, look at that. Hey, gravity's just like acceleration. I don't think that's true. Same with the apple thing. But in any case, Newton, let's see, what else is in this picture? You see the sun here, and it's shadow, or sun or the moon. It's tough to tell. But the water here reflects the tides, because the tides are influenced by gravity. And off here to the left is a copy of Philosophia Naturalis Principia, Newton's masterwork that kind of cataloged all his research. Now, this didn't come till much later, but just a brilliant picture there. Really like it. So somebody was very creative there. So he discovered gravity. He worked on his theories of gravity. He did work on optics, showing that white light, is made of lots of different colors. His 3 laws of motion. Those of you who have taken any physics are probably familiar with his laws of motion, and I think I'll briefly mention those later on here. Binomial series. I think I got a slide at the end of my presentation here that discusses the binomial series. But if you're familiar with Pascal's triangle and expanding binomials, then you've worked with the binomial theorem, except Newton did it for numbers that weren't integers. So instead of a plus b quantity squared, what about a plus b to the 2/3 power, or to the negative 1/4 power? So he made that quite general. A nice, brilliant insight. And of course, he laid the foundations for calculus, way ahead of his time. Now, despite all the odds against it, he graduated from Trinity College and was elected as a fellow of Trinity College, basically allowed to continue his work. Sizers usually didn't get that kind of an honor. It's something that's left as a puzzle to history to understand why he was so lucky. There's a couple different theories that he knew somebody, etc. We just don't know. But it was certainly against the odds. It's like being a third-class passenger on the Titanic and surviving. The first-class passengers had a pretty good chance of surviving. Third class, not so much. Crew, same thing. But he made it, and again, that was really good luck, and it was a transformative experience. He eventually became the chair of mathematics for that department when the chair at the time, Isaac Barrow, kind of left. It wasn't quite as magnanimous of a gesture as it might seem to our modern eyes. He left to take another position. But it allowed Isaac Newton to become chair, and that gave him the opportunity to do research at leisure. So he continued his work in optics, and he built one of the first, he built a Newtonian telescope, and it was made using more or less a parabolic mirror, which had better optical properties, and he did it to also investigate his theories of light a little bit. So word about this telescope spread to an organization called the Royal Society. And this is kind of like a nice peer group of people who were interested in all things science. They would meet and talk about their discoveries, etc. So it was a pretty prestigious organization to belong to. And they got wind of his telescope, so he built a version of his telescope and gave it to them. And they were really, really impressed. They're like, wow, this is cool. This is really, really cool. And they elected him to the Royal Society. And let's see, what year was that? It was 1672. So, what was his theory of colors? His theory of colors, his theory of light, said that light is composed of many different colors. It's made up of particles. And when he discussed this theory with the Royal Society, it didn't get the nice warm reception that it expected. At this point, Isaac Newton had been dealing with these theories for 7 or 8 years. To him, these ideas were like crystal clear. It's like, oh yeah, it's clear as day that light is composed of particles. We know nowadays that light has kind of a dual nature. Sometimes it behaves like a particle, sometimes it behaves like a wave. But back then, we didn't know as much as we do now. This led to some controversy. In particular, a couple people that reviewed his work, Robert Hooke, were a little bit cool to the idea. They didn't like it so much. And this frustrated Isaac Newton, who thought that this stuff should be as clear as day. Now, this picture here shows one of Isaac's experiments, actually a couple of his experiments. The one on the left is with prisms. The one on the right exhibits some of Isaac's strangeness. In order to try and better understand light, its properties, etc., he did a couple things. One was that he stared at the sun for about as long as he could and then closed his eyes. You've seen, when people take a flash image of you, you can close your eyes, you see that little spot. Well, he stared at it long enough so that it would burn an image in his retina, and he could kind of close his eyes and kind of study the sun at his leisure. Of course, what happened was that he had to spend 3 or 4 days in a darkened room before his eyes forgave him. The other thing that he did, which was kind of strange and is illustrated here, is he took a bodkin. Basically, think of it as a sewing needle, and he put it behind his eyeball and kind of moved it around just to see what would happen. Isaac had some peculiarities. He was definitely a little bit strange, but then again, genius often is. So there's no authentic picture of Robert Hooke that survives. This is Christian Huygens. They were a couple of the gentlemen that were a little bit cool to his ideas about light. Well, this frustrated Isaac, and he swore forever. He's like, that's it. I am not going to publish, because it embroiled him in controversies, and he didn't like that. He just wanted to be left alone forever to deal with his stuff. Then it was in 1684. Fast forward a little bit here, actually quite a bit. And Christopher Wren, Robert Hooke, and Edmund Halley are having lunch together. Now, Edmund Halley is a familiar name to you. Where have you seen the name Halley before? The comet, yeah. Halley's Comet. I think it last came around in like 1976 or 80-something maybe, but it comes around every 70 or so years. Halley was not the first one to see it, but he's the first one to figure out that it was the same comet that came back, periodically. And once he did that, it became known forevermore as Halley's Comet. He was an amazing guy in and of himself. He was a ship's captain, cartographer. He did a lot of stuff. But his lasting contribution to science here is a little bet that he engaged in with Christopher Wren and Robert Hooke. Hooke was a big braggart, and Hooke was bragging that, I got a challenge for you guys. If you guys can figure out what shape the orbit of a planet would take if there's an inverse square law due to gravity, I'll pay you the equivalent of 2 months' wages. So it was a pretty generous offer. Now, if Christopher Wren thought more about it, no one knows. But not Robert Hooke, but Edmund Halley became a little bit obsessed by it. And he called on Isaac Newton about 9 months later when he had a chance, and he says, hey, we got this challenge here. We want to know what the shape of the planet's orbit would be under an inverse gravity square law. And Newton applied immediately. He's like, oh, it'd be an ellipse. And Halley was struck. He said, well, how do you know that? He said, oh, I calculated it. And he couldn't find the calculations, but he promised to reproduce them. And when he did, Halley saw what he reproduced, and he says, wow, this is great stuff. This is the beginnings of some really great stuff. So he encouraged Isaac Newton to go a lot further and discuss his researches in greater and greater detail. And the result of it was the Philosophia Naturalis Principia Mathematica, the natural principles of mathematics, mathematical philosophy. So this book is, a godsend to people trying to understand the natural world. So it was published in 1687, and it just explained so much. Now, Newton made it intentionally difficult. I mean, even the modern version, now this was written in Latin. I've got a version that's translated and annotated. Every now and then, I try and get motivated and read it. And after about a page or two, I'm like, nah, I think not. It's really, really challenging, even annotated and translated here for me. But it was a beacon to those people who could follow. It explains so much about the world. It displayed the slosh and roll of ocean tides, the trajectory of a cannonball, all the heavenly motions of the planets. I mean, all this stuff became crystal clear. So it was amazing. Now, in publishing this book, Newton used a lot of classical work. He didn't use his modern calculus except where he absolutely had to. And his version of calculus was discovered earlier than Gottfried Wilhelm Leibniz. But Leibniz did something that Newton didn't do, and he published his work. Well, people around Newton said, hey, there's this guy who's publishing, your calculus. He stole it from you. And Newton got a little bit upset. And actually saying a little bit upset is maybe a bit of an understatement. They became, they hated each other at the end of their lives. And Newton's grudge lasted well beyond Leibniz's death. His death didn't put an end to his grudge. 20 years after Leibniz died, Newton was still bitter about the dispute that somebody would suggest that the calculus that was discovered was something other than his own. Newton, by that time, had been elected head of the Royal Society, and he formed a little committee to look into this controversy over who discovered calculus. Well, Newton chaired the committee, he put all his friends on it, and then he secretly wrote the conclusion. Guess what the conclusion was in this unbiased committee? Shocker, yeah. It was Newton that discovered calculus first. Big surprise there. A little bit more of a wrap-up on Newton. He was a bachelor all his life, and I think it was in the 1690s. He served as a member of Parliament. He was also given the job as Warden of the Royal Mint. And in this capacity, he had to oversee the production of coins. Now, this was a big deal back then because England was at war off and on with France. And in order to secure the realm, you had to have a reliable currency to pay off your troops. Otherwise, they're not going to fight for you very hard. So it was a big deal. It was an important job. And in that capacity, he was really diligent. He became a justice of the peace in 7 counties of England so they could swear out warrants. He had a bunch of informants that worked for him. He sent 80 men to the gallows. And I think they were, back then, the penalty for counterfeiting and coining and clipping was to be hanged, drawn, and quartered. And I'm not going to explain what that is to you now. It's pretty gruesome. If you want to look it up, I'm sure that you can find it on Google pretty quick. Uh, what else? Let's see. There was something else I wanted to say in connection with that. Oh, yeah. Who's got a quarter on him? You're familiar with a quarter, right? What's interesting on the sides of that? The ridges. Why are they there? Anyone know? Why are those ridges there? I mean, actually, I think it's a little different. Back in Newton's time, what people would do is they would take their coins, which were made out of just pure silver at the time, and they shave a little bit off. Take a little file and shave it off, or clip some off. And then they would accumulate all that. They'd take the quarter that they got, take off a little silver, and then pass it off as being worth a quarter still. Well, if you do that often enough, then you're going to make a little bit of money with all the shavings and clippings. But having these ridges on it makes it really, really clear as to whether or not somebody shaved it or not. And this was one of Isaac Newton's ideas. So, thank you. Good catch. So, you can see Isaac Newton even today. In fact, speaking of Isaac Newton, where's Newton in the news today? Does anyone know? Newton's in the news. I just saw it last night off the west coast of California. There's a hurricane named Newton heading up the coast. I just kind of laugh. I'm like, this is too funny. I'm going to be lecturing on Newton today. All right. A couple more things about Newton. He was famously distracted. When he would wake up in the morning, he'd be kind of struck to a standstill by the onrush of thoughts that he would get. He'd rise out of bed and he'd just sit there, in study, contemplation. His cat, Melchior, grew fat on Newton's leftovers because Newton would be asked to go to the dinner table and he'd walk out the front door, in thought. And then he'd realize that, oh, wait, I shouldn't be here. And then he'd walk back to his study, completely missing dinner. So his cat certainly had a good time at his expense. During his time in Parliament, the only recorded instance of Newton speaking at all was to politely ask that a window be shut. So, but he did spend 2 years in Parliament. Perhaps a few last thoughts here as to the source of Newton's genius. I mean, nobody else other than his niece, Catherine Barton, was outstanding in any intellectual way other than Newton. So where did he become so smart and gifted? Certainly he had lots of opportunity. And in fact, he had great opportunities and golden opportunities. But that doesn't explain it all. Now, a couple thoughts from Newton himself. He was asked how he discovered his theory of gravity. And he said, by thinking on it continually. And in this, he had a little bit of a commonality with Albert Einstein. Einstein had a capacity to keep problems in his head for a long period of time. There's an instance I remember reading about him in which he was in a crowded room feeding his baby and bouncing him on one knee and then writing something in a journal with his free hand. So he was able to just really concentrate and block out a lot of other stuff. Now, another quote from Newton says, if I have seen a little farther than those who have come before me, it is because I have stood on the shoulder of giants. Those giants would include Descartes, Kepler, Galileo, and Boyle. And certainly, again, Newton was lucky that he came along at the right time. There had been a lot of groundwork done for him by Galileo and Kepler. I'm not as familiar with Boyle. He did work on pressure, etc. Descartes had introduced geometry or algebra into geometry and enabled us to study equations rather than just graphs. So again, Newton was pretty lucky in that one. Here's his laws of motion. If you wanted to take a quick look at those, that's not really relevant to our discussion, But if you're taking physics, you've seen these laws of motion. And we're going to start applying his calculus to these kind of problems, tangent problems, where we're trying to find a line that just touches a curve. Here's the binomial theorem in kind of a nice integer version. Newton went on and did it for a non-integer version. So just amazing stuff. So here's Newton's generalized binomial theorem. You're not responsible for any of that. Now, how does calculus change things? Well, in working with calculus, or before calculus, you can find the volume of a box. But when you're working with calculus, at the end of the semester, what you'll be able to do is find the volume underneath a curved surface. That's a lot more challenging. With calculus, you can find the height of a curve just by evaluating a curve at a point. In calculus, soon enough, in like chapter 3 or so, we're going to start finding the maximum height of that curve. Slope of a line. So the first one's the average slope of a line. Second one's the instantaneous slope of a line. It just really changes the landscape of what you can do, because calculus is going to give you a way to deal with what's called the infinite. So there you go. Isaac Newton. Pretty amazing figure, and I hope you enjoyed learning a little bit about him. Any questions on Isaac? Okay.